Okay, judging by this slide, I would bet you would think we're talking about arithmetic and geometric sequences or series, and you'd be right. The new chapter, chapter 9, by the way, the last chapter before next semester. That's a long chapter. Yeah, you're not kidding. Okay, so this is the last. We only got through chapter 9, and anyway, it's kind of a longish one, and it has to do with sequences and series. And let me just like give you a big picture. If I said wanted to start with 28, add 3 each time, 31, add 3 more, 34, dot dot dot, and I said I wanted you to add up the first 24 numbers in this series. There's formulas that'll help you do that. Now, this one particularly is easy enough that you could just keep adding 3 and take all the numbers and add them all up. But there's special formulas that help you do that. Do you remember back to learning things like this? You have a $2,000 loan. U sub n is equal to U sub n minus 1. Does that ring a bell? It was about any random term is given by the term in front of it, and then if I multiplied by 1 plus 0.04 divided by 12, and then minus 200, that was $200 payments monthly, 4% interest. Does all that kind of stuff ring a bell? All right. The main thing, I don't expect you to be a master of that. It's okay if you're not. You might have forgotten it. But do you get that this had to do with a random term? And this was the random term not really random. It's the term right in front of the other one. Okay. So if I make a list like 25, 30, 35, etc., and I pick any random term here, I could have picked this one. We would have called it U sub n. Now we're going to call it A sub n. It's not that big of a difference. I've seen it on the ACT as A sub n. I know somebody else who works in a different school district, and they never use U sub n. They just use A sub n. It's the same idea. Okay, so then if that's any random term, what would this one in front of it be? It would not be A sub n. A sub n minus 1. Does that ring a bell? Do you remember that? Because the one that's bigger than it, like let's say this was a 7. Do you get this would want the one in front of it would be A sub 6 would make more sense? 7 minus, there you go, now it's snapped in. Okay, so how about this? The one in front of it should be A sub n, what? Plus 1. You're going to see that terminology. When you see A sub n, I want you to think, oh, you're saying any random term. When you see A sub n plus 1, you're saying the one after that. The term right after that. All right. Okay, so here, I'm just going to jump right to the point. A typical question either says, here's a crazy formula, tell me the 4th term, or write a formula for this. And so this one, do you get it just adds 5 every time? All right, so here's how you write it. There's a formula for this. Write this down. A sub n is equal to, that's saying any term will be A, and these formulas are super important. It's not, like the last few chapters we've had, you really haven't had to memorize much. These formulas are it. Like in this chapter, if you've got all the formulas figured out and know how to put numbers in them, then this chapter is easy. But there's a lot of formulas. Like this one, I came to it, I've taught it for 4 years now, and I still had trouble remembering it. I had it written down, so I was okay, but the point is, they're not super easy to know. All right, A sub n is A, which is the starting amount. You might want to label this. In this sequence, what was the starting amount? 25. So any random term, like the 10th term, you start with the starting amount, and then you add, I will get to your question in a second, but for right now, this is not a good time. The d times some number of times. Okay, what the heck is a d again? It's the common difference. Yes, the common difference. What is the common difference? Well, the difference means subtract. 30 minus 25 gives you the common difference, which is what? 5. The common difference is 5. It just adds 5 every time. Well, how many times do you add it? Well, let's just do a simple one here. If I start with 25 and I want the third term, I would add 5 twice. Notice if I want the third term, I'm going to add 5 twice. Do you get how that's 1 less than 3? I don't add 5 3 times. I add 5 twice. It's 1 less than however many I had. So who knows what to put here? If I have the nth term, I would not do n times d. I would do what? N minus 1. Very good instincts. There's your formula. Got to know that formula. Memorize it. Write it down. Got to have that one. Here's a typical way you'd use it. We'd give you a formula, and we'd say, find the 100th term in this sequence. When it's something nice like counting by 5s or 10s, that's not that hard. You could even do it in your head. So I'm going to give you one that's not like that. I'm going to start with 28, and I'm going to add 4s. 32 plus 4, 36. And I want to know, actually, I want to know the 101st term. 28's the first one, yep. And I want to know the 101st term. Hint, that formula you just wrote down, which I hope you wrote it down. You're going to use that to find any term. In this case, which did I ask you for? A sub 101, the 101st term. And it depends on what you start with, of course. And then the common difference is important, which is 4. I'm going to pause for a second while you figure it out. I made this work out pretty nice, so you won't, you'll actually be able to do this in your head really easy. Okay, so I hope you were able to find the 101st term. Here's how it would go. You'd start with A plus n minus 1. That means 1 less than whatever term we want. I did that on purpose. You see why I picked 101? So then it would work out to be 100 right there. And then times d. All right, so then what's our numbers? What's our starting number? 28 plus n minus 1. It happened to work out to exactly 100 because it was 101 minus 1 times d. And what is d in our case? 4. So that makes that 428. Raise your hand if you had that one right. Awesome. Okay, do you see how that little formula is handy for like finding the nth term? It is. It's pretty handy. All right, so then what if it's a geometric? They look like this. 20, and then I'm going to times by 2. 40 times by 2, 80, dot, dot, dot. Again, not hard to do one term at a time, but what if I say I want to know what the 10th term is? It'd be handy if you had a formula for that. Would you agree it probably depends on what number I picked to start with? It's in the formula. What do you think would it have to be in the formula also? Yes? Exactly. What's the official name for the number you're multiplying by? Starts with an R. The ratio. The what kind of ratio? The common ratio. Okay. So in this case, to get the ratio in question is 40 over 20, which does reduce to 4 over 2, or also known as 2. And couldn't you just say it's what you multiply by? Yeah, but it's called a ratio, so I want to show you why you can divide two numbers to get it. All right, so that's our common ratio. Yes, of course that matters. Of course what you start with matters. And then it's how many times do you want to multiply by that ratio? Same idea where if I want this term, I'm not going to multiply by it 3 times, even though it's the third term. I'm going to multiply by that magic number twice, 1 less than it. So somebody, without looking forward in the slides, should be able to tell me a sub n, my any term, would be given by, take a shot at it. What do you think I'm going to start with? Yes? A times, be more generic though, because it's not always 2, r to the, you are exactly right. Very good. Write that one down. That's the second of 5 formulas you have to know. You asked about how many there were as 5, and this is number 2. Not 5 today, 5 total. So today we learned these 2. Tomorrow we learn, well, not tomorrow, it's actually a Saturday, but the next lesson we do, you're going to learn 2 more, and that's about like, instead of saying what's the 20th term, it's what do the first 20 terms add up to? Now there are times in life that that's pretty handy. Like let's say there's a salesman who is trying to increase how many people they talk to. Okay, so they talk to 6 people on their first day on the job, and they're like, as long as I talk to like 1 more person each day, it'll be pretty good. I talked to 6 people on the first day, then I talked to 7 people the next day, 8 people the next day. They're trying to just slowly grow, right? And then they're like, how many people did I talk to at the end of 2 weeks? Total. See what I mean? See how that could be handy? There's a formula for that. All right. All right, so this little formula, I'd like you to try finding for me the 10th term in this sequence or series. Well, sequence is what we're doing today. Series is where you actually add them all up. See, so this one's just a sequence. What is the 10th term in the sequence? And pause for a second while you give that one a try. All right, so 10th term, a sub 10 is a, the amount, 20, that you start with, times r, the golden ratio, no, not the golden ratio, the common ratio. It's 2 to the n minus 1, well, that's 10 minus 1, which would be 9. 2 to the 9th is kind of a beast to figure out, but it's not impossible. Here's how I'd do it. First of all, if you had a calculator, yeah, but you're not going to have a calculator on this one. On the test, you won't. Would you agree that's an 8? Would you agree that's an 8? Would you agree that's an 8? So it's really 8 times 8 times 8. That's not as bad. Wait, it's 8 times 8. 64 times 8? No, I don't have it memorized, but it won't be that hard, see? All right, so then I go 8 times 64. 8 times 4 is 32. 6 times 8 is 48. 51, 512. There we go. Okay. All right, final answer. 20 times 512. This was 512. 20 times that. So if I do shortcut math, 2 times it and then add a 0 at the end, 2 times 512 is 1,024, and then add a 0 at the end. 10,240. Raise your hand if you had that one right. Excellent. Okay. Yes, that's about as bad as they would get. And yeah, you have to multiply, but come on. You're an honest pre-calc. You can multiply. It's just multiplication. All right. Okay, so that is almost it. Almost. All right. So what's the almost part? Well, sometimes they give you these weird formulas, and you have to take the weird formula and figure out what it means for what's the next term. All right, find the slide that looks like that one. These are the typical ones that we would torture you with. That phone needs to be turned off. Thank you. All right, so number 1. You're not paying attention. All right, number 1. What's a sub n mean? I mentioned this a million times. Yes. The random term. A random term. Any random term. An kind of looks like any to me. Sorry about the squeakiness. Any term. That's any term is given by, and then they say all of this stuff. And then they say to start with 1 and then keep going what? Up or down from there? So you start with n as 1 and you go up from there. That's all you got to do is stick a 1 in for n and see what happens. I'll put in a 1. Oh, I found a sub 1. I am sticking in a 1 and a 1. And I get 5 to the, what is 1 minus 1? 0. 5 to the 0, what's that equal to? 1. And what's 3 to the 1? 3. That's 1/3. Do you think that would be a problem? Give me that. You can have it back later. If your mom's in the hospital, tell me. All right. 1/3, comma. Now we're going to put in 2. 2, 2, 2. Everybody, for yourself, figure out what you get when you stick in n as 2. Hint, it's the second term. Not super hard. I'm going to pause for a second. Let me give that a try. Here we go. Okay, so 1/3, and then you suck in a 2, and then you got 5/9. Did you get 5/9? Raise your hand if you did. Awesome. That kind's not that bad. You just stick in 1, see what you get. Stick in 2, see what you get. It's not that hard at all. This one looks weirder, but it's the same basic idea. What are you going to start sticking in? Hint, there's your little list. Take a wild guess what the first thing is you should stick in. 1. And then you keep sticking in numbers, and you could stick them in there infinitely, right? And so therefore, you'd put in 1 and 2 and 3 and 4, and that means you can just keep going forever. When we do our sequences, we're going to be saying like from 1 to 8, and then we'll be, what that would mean is stick in 1 and 2 and 3 and 4 and 5 and 6 and 7 and 8. Okay. But for right now, this is just saying stick in 1, see what you get. 2 times 1 is 2 minus 1 is 1. Stick in 2, see what you get. 2 times 2 is 4 minus 1 is 3. 1 comma 3, keep going. Get a few more terms. Typical question, find the first 4 terms. Yes, sir. Good question. This means from 1 to infinity. I know you've never seen that terminology or that like notation before, but that means go from the low number to the high number, and you always go in steps of a whole number. So you start with 1 and you just keep going. Now, of course, you're not going to go to infinity. There is ways to add up. This is a really weird concept. How could you add up an infinite number of numbers? You actually can, but there's a special requirement. They have to be fractions that are descending, and if so, you can add up an infinite number of fractions. I know it seems crazy, but that's the reason that I can get out that door. Because to get out that door, I have to go halfway to the door first, right? And that takes some time to get halfway to the door, wouldn't it? Okay. And then I'm going to do that an infinite number of times. It seems like you would die before you get to the door because it takes an infinite amount of time. It doesn't, though. You can add up an infinite number of fractions and have it equal a number. Because I know from here to the door, that's about 20 feet. I can get there. Half of that distance, which is 10, plus another halfway to the door, which is another 5 feet, right? And then another half of that, and each one of those, eventually, when you add them all up, adds up to 20, because that's how far it was to the door. You can add an infinite number of fractions, but you can't add an infinite number of whole numbers. Like if I keep making my numbers bigger, like 10 plus 20 plus 30 plus 40, you can't add that up because it's just getting bigger, and you can keep going forever, right? But it is weird that you can add an infinite number of fractions. All right, did you hopefully stick in a few more numbers and figure out it was 1, 3, 5, 7? Do you get that's just the odd numbers? Once again, it'd be kind of fun to go back to an elementary school classroom and when they're introducing odd numbers and say, of course, kids, this is the equation for the odd numbers. You learn so many things where it's like now you know a really complicated way to do the odd numbers. Or, you know, like, as everybody knows, log base 6 of 6 is equal to 1. So we'll put that in place of 1 today, Jimmy. They did logs today. It doesn't even like sticks. Okay. So, now you get to be the confused kid. That one kicks a lot of people's butts. Now, I'm going to give you one thing that should help. A sub 1 is the first term. The first term is 7. It's what it's saying right here. Think of that as if you're supposed to find the first 4 terms, you already got the first one. It's 7. From there, it's not that bad. Half the class is going to get it right away. Let's see if we can get it more than half. I'll pause for a second. Try to figure out the first 4 terms of this. You can do this. It's not that scary. Okay. So, did you figure out that you take this number, and this is the number after it, is 2 minus the number in front of it. To get this term right here, see, this is the next term, you take 2 minus the number in front of it. What is 2 minus this number? -5. And then you do it again. 2 minus this number. Well, it's 2 minus -5. It's 7. And then 2 minus 7, I think you can, this is kind of like the thing on the shampoo bottle that says lather, rinse, repeat.
2 minus 7 is not -5.
My wife is very frugal, and of course she doesn't lather, rinse, and repeat. She just washes her hair once and it's good enough. She talked to her sister and she was like, "Are you serious? You never actually repeat?" For her whole life, she'd always lathered, rinsed, and repeated because it said so on the bottle. Yeah, use twice as much stuff. It's perfect for the company. They're burning through the soap, and it's great. They need more faster. I'm not even going to ask. I'm sure there's some of you that have to, and I'll be honest, if you have lots of hair, it's different. You might have to lather, rinse, and repeat. But for most guys, you can probably get away with not repeating, guys, just so you know. Procter & Gamble is probably going to censor my video. They're going to hear this and shut me down. If I disappear this weekend, you can blame Procter & Gamble. All right. That's the hardest kind. I need to know how many of you had figured it out before I showed it to you. All right, that's about half of you. That's not bad. All right. There is some on the homework that'll be like that. Let me show you what I think you should do. Here we go. The homework starts right there. And I want you to do this one, this one, this one, and this one. They are strikingly similar to the ones we just did. They will be a great, easy review. And for those of you who are like, I still didn't figure out that one, here's another one just like that, number 7. And you'll have to know how to do that, so practice it. The answer key is, of course, there, and it'd be wise to look at that. All right, next. On this page, we are skipping both. Moving on. On this page, I'm asking you to do 14 and 16 and 22 and 23, and that's it. Because I know there's more questions after that. Why am I only giving you a few? Because if you actually do the ones that I assign, that'll be enough. And it conveniently leaves you a few extra problems to do on the review day. If you say, well, there was no problems I could do, you're lying to yourself. Because there's a whole bunch of problems right there that you could do. I had to skip a bunch of them. And there's a key for it too, right? So that's a thing you could do on the review day for the test. For right now, if you just do the ones I had circled there, I think you'll be okay. I get these are kind of strange, but it's day 1 of this unit. Of course, you're not experts at this yet. And this unit's a long unit. Okay, that's all I have for you for today.